In this week, we are going to talk about next topic, MATLAB matrix operation. So as you may recall that in last week, we have already shown you how to use square brackets to create a matrix or array, right? You can use square brackets and a semicolon to create a matrix, okay? But today we are going to take further step. We are going to talk about what you can do with the matrix that you create, okay? So we are talking about matrix operation. And as you can see right here, we are going to take two different parts. The very first one is matrix index and operation. In the second part, we are going to take, again, an example based on the medical imaging. So we are going to talk about what is the local image process and how we can perform the resolution adjustment. Okay. And again, you can download all the handout and materials from our website. So let's jump to the very first part, matrix index and operation. Okay, we are going to spend some time to discuss this issue. So very first things, we'd like to talk about index. And I have to say, index is kind of the system or efficient way that we can deal with the massive data, that we can handle massive data. Okay, this is very important. For example, if you have a matrix on hand, the size is pretty like 1,000 by 2,000. How can you find a single element from this kind of the big matrix? Okay, we definitely need some way to figure out, right? So what you can do right here, let's take this picture as the example. Okay, you can see so many
Taiwanese army right here.
But the key question is, I'm going to ask you to do me a favor. Can you find out who forgets his tie? Everyone looks like to wear his tie, right? But some guy right here forgets his tie. So I'm going to do this. Okay, so you can take a close look. Can you find out anyone forgets his tie? How can I tell you? Yeah, that is a good question. How can I tell you? I know where, but I don't know how to tell you. Any other answer? So many of you did raise your hand and say that you did find some guy forget his tie. But is there anyone, I don't know, do you have any way to describe where? It's a big problem. It's a big issue, right? How can we describe where? People may say right hand side, there. We always do this. Does he forget about his tie? You may say, no, right side. Okay, this one, no, right side, no. It's pretty stupid, right? Or you may say, come on, teacher, is in the right part of this huge army right here. Okay, right side, maybe right here. But where? So you may say upper part, lower part is pretty stupid, right? But we always know, of course, this guy, maybe he just, I don't know, wakes up too late or something, I don't know, something, I don't know. But do we have for example, a coordinate system to help us identify this guy is located? For example, I think this guy is standing at the second line. This is the first line, right? He's standing at the second line. And if we count from the most right-hand side, then he is the 1, 2, 3. He's the third guy. So this is one way that we can say not simply there, but I can describe the second row or second line. From the right-hand side, you can count the 3 guys, then this is the guy you want, right? And a pretty similar question, if I'm going to ask who wears wrong color, let me help you. Maybe I can enlarge it. Okay, some guy within this region. So which one? If you find it, just raise your hand. Let me know. Okay, 1, 2, 2 of you did find it. But can you try to tell me where? For example, this is the first line. This is the second line, third line. So which line? Fourth, fifth, third, right? Okay, so right here, this line. Okay, so let me count from the most left side right here. So which one? This is 1, 2, 3, right? Yeah. So I have to say, yeah, 3 and also 3. The third line and the third guy right here, third column right here, you can identify this guy, just wear the wrong color, right? Okay, so this is an example. If I do have some massive data, I think this guy is just standing like a matrix, okay? Line by line, crystal clear. You can see every single line is aligned with each other. It is a pretty good army. And I have to emphasize that this picture is retouched, remade by me. So this is not a real one. It is not their problem, but I did something for this, okay? So they are pretty good guys. This is not their fault, okay? So you may find out what we just discussed is kind of the index system. Or you can simply say it is kind of the coordinate system. Okay, so you can try to remember this point. Within MATLAB, there are two different index systems. Okay, what you should do right now before I can tell you more, I'd like you guys to do one thing. Look at your handout. Please try. I'd like you to remember, to recall. Can you simply create this kind of the A, of course, in uppercase, A matrix? I'd like you to key in 25 elements within this A matrix, and it should be 5 by 5 matrix. So try to do it. Think about this. You may use the square brackets. You may need to use the semicolon to change the row, right? So try it. Create this uppercase A. You can simply do it within the command window area. But I just want to make sure that all of you remember or really learned that how you can create this kind of a matrix, 5 by 5 matrix. And I want you to put in exact number right here so we can make sure that the subsequent practice you may have the same result with me, okay? So do it now. What you can do right here, remember the variable name start with an uppercase A, right? Then you can use the equal sign. Of course, this is kind of the sign can help you assign something from the right-hand side to the left-hand side, okay? And then you will need to use the square brackets right here, okay? And then you need to put in all the numbers 12 to 33, 4, 46. Then you need to put a semicolon, right? So more like 12 space 2 space 33 space 4 space 46, right? Then you are going to change row, right? So you need to put now this one, semicolon, right? Again, what you're going to do is 3 space 7 space, I don't use it anymore, it's pretty tired. So I'm going to finish it so you can follow me. Okay, so you should be able to do this, right? If you did it right, you will see a 5 by 5 matrix printed out on the command window. Okay. Okay, so if you get your matrix, just raise your hand. Let me check. Okay, I think half of you just did this. Okay, good. You can put your hand down. Okay, I think this is a very basic practice that what we did in the last week. So if you totally forget about this, I do hope that you can remind yourself right now, okay? Okay, so I'm going to take the control back. You will have time later, don't worry, okay? Okay, so let's continue. Right now, we are going to talk about one thing that if we really want to find out something or some guy, for example, in the last slide, right? In MATLAB, you will have two different systems, two index systems. The very first one is so-called column-wise index. And the idea is pretty simple. You can take a look right here. This is the way that we number the order. Start from the very first row I have to say this is the first row. Okay, let me put an arrow right here. This is the first row. Okay, and this is the first column. You can see right here. So start from the first row and the first column. We can simply label the element. Start with 1, right? Then we follow the column, the direction of the column. So we say this is column wise. First column, 1, 2, 3, 4, 5. Once you finished all the elements within this column, you will jump to the next column. And again, you need to start from the very first row. So this is the 6, 7, 8, 9, 10, right? So you go for this order, so on, so on. You finally will go to the final column right here, 21, 22, 23, 24, and 25. So now, if I ask you, can anyone tell me where is the index or location of the 64? Just give me just one number to represent, okay, the location of the 64. You may easily say 13, right? Because this is a label using the column-wise index. Okay, it is given a label like the 13. So how about 84? Where is the location or index of the 84? You may easily find out just 23. So this is kind of the way that we may have the consensus. Okay, we may have the common idea. So we do have another index system like this one. It is so-called row and column index. Okay, different from this one, this is solely based on the column-wise direction. This one consider both direction, row and column. So I think all of you may be pretty familiar with this kind of a system. For example, this element is located in the second row, second column. So you would say 2, 2. If some element right here is located at the second row and the fourth column right here, then you would say 2, 4. Okay. So again, I'm going to ask you, can you tell me where is the location of the 46? Or what is the row and the column index of 46? Just give me two numbers. I think the answer is pretty easy, right? It's 1, 5. Okay, so this is the way. If we do have a pretty huge element, we cannot always say next, 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 right side, right side, right side. We don't do that. We can simply use the number, use the index system to do this, okay? So you may find out for any single location, you can say it is located in the 18th index, or you can say it is located at the 3, 4 index. Okay, you have two different ways to say so. So every single time when people hear something like a single value, we will immediately know that this is following the column-wise index. But if you hear more than two numbers, for example, 3, 4, 5, that means this is a three-dimensional matrix, right? 3, 4, 5. You not only have the row column, you may have another or third direction like the slice or something, okay? So you're going to do this right now. I'm going to give you back, okay? What you can do right here now, you can try to type these kind of things, okay, in your command window. So you can put A, the variable name, in the first letter right here. Then you can use the parentheses right here. Within the parentheses, you can put a single number or two numbers. But do remember, if you are going to use a row column index, between these two numbers, you need to put a comma right here. Okay, this is required. You cannot simply use the space. No. Right here for the index system, between row and column, you definitely need to put this comma right here. Okay, so try it. You may find out for these two different method, you may find out the same results because you can get the value located at the 18th location or maybe 3, 4, the third row and the fourth column, you always get the 6, right? If now we know how to get a single value or the value from a single position, can we do more? Can we get the values from a specific range of the index? For example, can we get all the values from the second column? Okay, so think about this. If I'm going to go for the column-wise index, is there any way I can do this? Think about this. For column-wise index, you should not use two numbers. But for this case, because you are going to acquire or get the value from a specific range, right? So you may key in this way. Again, A with the parentheses right here, and then you can see I use 6 column right here, right? And 10. Again, what does column represent? Within an array, column represent from the left-hand side to the right-hand side. So basically, 6 column 10 equals to 6, 7, 8, 9, 10, with using 1 as the increase, right? So you can easily to find out that using this kind of the statement right here, you may easily get the value, not simply 6, 7, 8, 9, but the corresponding value located in these 5 index right here. So you can see 2, 7, 6, 5, 4. You can get the answer, right? If you are trying to use the row and column index right here, you may find out, again, you need to put a comma right here. But right now, what you should do is for the row, you can see right here, I'm going to get every single row within this column, right? So now you may see I only put a column right here. In this way, if you didn't put any single number on the left-hand side or either right-hand side of the column, it simply represents O. Okay? If you just use a column, that means within this dimension, I'm going to get everything. That means O. O index is right here, okay? Okay, so if you put right here, that means you are going to get the values from the second column and all the rows. So you may find out the answer is like 2, 7, 6, 5, 4. So please do it right now. And I'd like all of you to compare what is the difference between these two results. What is the difference? Think about this, okay? But I'm going to give you 30 seconds to try to key in this command in your command window. For the left-hand side, the column-wise index, you may get the output like a, I don't know, maybe just a 1 by 5 array, right? 1 by 5 array. But for the answers that acquired using the row column index, you may get the answer more like the 5 by 1 array. So the difference is the dimension. Even you did get 5 identical value, 2, 7, 6, 5, 4, the dimension is pretty different, okay? So do remember one thing. When you are using the column-wise index, this method won't preserve, it won't maintain the original dimension. So it's always go for 1 by something, okay? 1 by 5, 1 by 6, 1 by 10, anyway. But for the row column index right there, it will preserve the original dimension. The original matrix right here, you can see right here, it just looks like a 5 by 1 array, right? So if you use this kind of a row column index, it will preserve the original dimension, the original appearance that how it looks like, right? Okay, so this is the main difference right here. But again, if you only care about the value, both ways can help you to get the value. Okay. So let's go to the next one again. So right here, we're going to again get a value from a specific range of the index, but now you can see it is not for a single column. It's more like, I don't know, a small or subset matrix right here. So you can see I'm going to get the value from the second to fourth row right here, and the third to fourth column right here. Okay, so basically I'm going to get the value when you are using the column-wise index from the 12, 13, 14, 17, 18, and 19. Okay, but for the row and the column index, you can see it's just exactly what we mentioned, the second to fourth row and the third to fourth column right here. So based on what we mentioned before, you may find out it is not that hard to understand. You can put the line right here, the code like this one. For the column-wise index, you may find out, again, everything is pretty similar. But right now, within the parentheses, you are going to use these square brackets. Square brackets can help you to create an array, right? If you simply put something like a parentheses 12, 14 with a space right here, and then 17 with the colon and 19 right here, what will happen? Let me show you. Okay, if you simply do this right here, I need to see the number. Okay, so if you simply do this, you may find out some error message right here. Because right now, please take a very close look right here. This one is an array. This one is also an array. But if you want to put the two arrays together, again, you need to use the square brackets, okay? You need to use the square brackets. So you can see MATLAB is pretty friendly. If you just key in something wrong, you can see MATLAB just he tried to tell you something. He tried to tell you something, invalid expression. And you can see what is the recommendation from MATLAB to construct matrices. Use brackets instead of parentheses. Okay, so what you should do right now, you can modify it by simply adding the square brackets right here. Okay, so with this one, you can get the right answer. You can check whether the value is right or not. 464, now this one, yeah, 36 right here, and finally 7. Okay, so you can see right here, this is the area right here. So again, you may see the output is follow the column-wise ideal 4, 64, 666, and 7. Okay, and pretty similarly, you can do it using the row column index. And now you can put a range for the single dimension. So for the row dimension right here, you can put 2, 4. That means 2, 3, 4, right? And for the column, 3, 4. So 3, 4. Okay, so this is the answer that you can get. So try to do it by yourself. I just want to remind you that you do need to use this comma as the separation when you are doing the row column index, okay? Okay, anyway, I'm going to show you the next slide. So this is another example. If I'm going to get the value from, now not the continued rows, but more like the second, followed by the fourth and the fifth rows right here. So what can I do? Okay, you can just keep trying, but I'm going to do this with you right now. Okay, let me put the PowerPoint on the left-hand side and MATLAB on the right-hand side. What I can do right now for the column-wise index, okay, I think it's pretty similar, right? What you can do right here, sorry, I should clean, okay. Again, you can simply put the index like 12, 14, 15, 17, 19, 20. But again, if you try to key in this way, again, you will get the error message. And this error message is pretty similar with the before, right? You can see it's just trying to mention you that to construct the matrix, use brackets instead of the parentheses. So that means you need to use the square brackets right here, right? Okay, so it will look more like an array. Okay, so now you can try to key in. You might find out the value from these 6 specified locations right here. So do remember, within the parentheses, this is the parentheses, right? You need to use the square brackets because this is the way that you can tell MATLAB within the brackets, these are the elements for the array. Okay, this is important. If you didn't do that, MATLAB get confused. It just cannot understand you, okay? So this is a language that you can communicate with MATLAB. But for or another way, the row column index. What should I do now? Maybe we start with the comma, because I know now this is the row columns index, right? So for the first part, I'm going to key in something definitely to identify the row number, right? And then for the second part right here, it should be the numbers for the columns, right? So for the columns, I think it's much easier. I can put maybe 3 column 4, right? Because now it's pretty similar to the previous example. Third and fourth column, so you may go for this. But how about the row? So you may say, I'm going to go for something like, I don't know, 2, 4, 5. If you key in this way, again, you will see the same error message. Again, it's just try to remind you, you should use the bracket. Use brackets, okay? It's so clear. So what you should do right now, do remember, if you are not using this one, you are using the space as the, I don't know, to show the different elements within the array. Do use the brackets, do use the square brackets to let the manager know that these are the elements within an array. Okay, this is pretty important. So if you do it in this way, you will get a result. And again, you can compare these answers with the previous one. When you are using the row column index, it will maintain, it will preserve the original dimension. You can see this is a 3x2 matrix. But for the column-wise index, it will simply give you 6 number, okay? Only give you the 6 number. So any question about this part? No? Good. Okay, so let's continue. Okay, so how about right now? We are not going to get the value, but right now we are talking about a different issue. Can we delete? Can we remove rows or columns from the matrix? For example, I don't really need the fourth row right here. Is there any way that I can remove this row from the matrix? Okay. I think the answer is easy. You can see right here. Right now, when you try to do something like the assignment, I'm going to assign, you can see the right-hand side. The right-hand side of the equal sign right here is more like the empty brackets. Why is it empty? Because for these brackets, you see no number within the brackets, right? So it is more like the empty matrix or null. Okay, that means nothing within the brackets. Okay, so you can do this kind of assignment. I'm going to assign this empty matrix to the fourth row. That means you are going to make everything within the fourth row become empty. Okay, get the point? Okay, so you can try it. You may find out the answer is just right here. It just simply skip the fourth row. Okay, so you can see 12, 3, 4, and 7. 12, 3, 4, and 7. You didn't see the 6. Okay, so that means the fourth row is removed. Okay. But for a column-wise index, I think it may be pretty difficult to do so. You may try. You may try. Let me do it. Can we do that using column-wise index? For example, the fourth row right here, you may say, I want to make 4, 9, 14, 19, and 24. I'd like to assign an empty array or empty matrix to it. Okay, you may find out it may work somehow. Just look pretty weird, right? You only get 1 by 20 values right here. It doesn't look like a matrix. Because when you are using the column-wise index, yes, you can remove something, but it is no longer look like a matrix. So personally, I don't recommend a column-wise index for the row or column deletion. Okay, you just go for a row column index. It's more intuitive. Okay. Okay, so Can you remove this part? Okay, and all of you to try. If I'm going to ask you to delete this part, what would happen? Delete I don't know, the row from the very first one to the third row and third and fourth column. Can you try to remove or delete it for me? Okay, try it. That's right. I think it won't work, right? Because it's just a part of the matrix. And when I try to delete this part, the matrix won't look like a matrix anymore. Because it's more like, I don't know how to say this shape. It's more like a U shape or something. I have to say MATLAB won't allow you to do such kind of the operation. There's no way. Because to delete such a small area, this doesn't follow the rule, the basic rule for a matrix, okay? Okay, so let me try it now. I'm going to remove 1, 2, 3, comma, 3, 2, 4, okay? Sometimes you don't always say this is a column. You can simply say it is 2, okay? 3, 2, 4, 1, 2, 3. I think this is more easy. Okay, again, I'm trying to assign an empty matrix to it. Okay, so you may find out the error message like this one. A null assignment can have only one non-column index. Okay, so that means you cannot break the shape of the matrix. Okay, you cannot break the shape of the matrix. Okay, you can remove a single row or maybe 2 rows. You can remove single column or 2 columns. That's fine, but you cannot just remove a part of the row or a part of a column. It is pretty weird. Okay. Okay, so I'm going to show you one more function. Okay, one more function right here. The function is the find, F-I-N-D, all come with the lowercase right here. And you can help find. Don't remember every single time when you see a new function, just help it. Just help it, okay, help yourself. So you can see help, find. You will see the description and the use of this function. For example, find can help you to find indices of non-zero elements. Okay, so if you input a matrix like this one, uppercase X right here, it will tell you the indices of the non-zero elements. So for example, what I can do right here, if I simply use find and I use the A as the input, what would happen? Sorry, now A is not the original A. I need to restore it. Now it's more like the 4 by 5. I don't like it. I want it to be 5 by 5. So let me use the comment history, come back right here. So now A is again 5 by 5. Okay, I just want to make sure this part. Okay, so again, I'm going to find, but use the A as the input right here. So you may find out it will give you the answer from 1 to 25. You can see 25 values right here. That means based on the column-wise index, every single element is non-zero, right? There is no zero within the A matrix, right? So every single column-wise index fulfill these criteria that there is no non-zero element, right? Okay. Can we try to ask this find function output row and column index? Can we do that? Yes, we can do this. But you need to understand one thing. You need to use the square bracket and this equal sign right here. For the left-hand side, you need to give 2 variable name right here. For example, R and C. R means all the numbers for the row, and C means all the number or indexes for the column. So again, I'm going to do this. Then you may find out this answer. You have see so many different numbers for R and so many different numbers for C, right? It's pretty confusing, I have to say. But I'm going to take the advantage of the variable viewer right here. I'm going to do this. I try to put the two variables together. So now you can see this is the number for row. This is the number for column. So the answer is 1, 1. The location for 1, 1. That means this number, 1, 1, right? Is a non-zero element. And the second, this is 2, 1. That means second row, first column. Again, it is a non-zero element. So on, you can just find out there are 25 combinations right here. Okay, so these represent the 25 row and column indices for all the elements. Okay. But there's one thing you can do more. So just take a look on this one. Take a look right here. If I'm going to ask more, I'm not interested in non-zero element. I'm interested in a specific value. For example, can I use find function to find out the element of the 6? Okay, can I find the indices for the 6? So as you may see right here, here is a 6, here is a 6, another 6, and another 2 6 right here. So I should get 5 indices right here, right? I should get 5. So this is a way, not only directly input the A right here, you can put some, I don't know, description. I have to say this is a description. But right now you may see some weird situation right here. I see 2 equal signs. And I have to remind you, when you are using a single equal sign, for MATLAB, it's more like the assignment. Assign something to the left-hand side, right? So if you really want to say something, I want to find out A equals 6. That means I want to find out all the elements with A, whether it has the number of 6. You cannot simply use one single equal sign because that means assign. It's pretty weird. Assign 6 to A, right? You need to put 2 equal signs together. Then MATLAB will get to understand that you are talking about something like the same or equal. Okay, this is a rule. So you can take a look right here. This is so-called relation operators. You have the equal. Do remember when you are saying something about equal, you need to put 2 equal signs together. If you are talking about something not equal, for example, A not equal 6, that means all the elements that the value is not 6. Okay, so you should use this one. This is more like the shift. I don't know how to say it. The key above the tab key. Okay, just take a look on your keyboard. Okay, this one. And then less than right here, greater than. I think this is pretty easy right here. And this is the case, less than or equal. Okay, this is a case, or greater than or equal. Okay, so you have so many different things right here. So please try to key in this kind of the code or command right here. I'm going to just copy it to the command window. So let's take a look what will happen. If you are saying something like this one, I'm going to find out the element has the number of 6, and I'm going to assign all the indices into this variable, IND. It's just a shorthand of the index, right? So you can find out, okay, 4, 8, 14, 17, and 18. We do have 5, 6 right here, right? Okay, so this is the way that you can use it. Pretty similarly, if you want to find out the value larger or equal to 6, you can simply change the description like larger than and equal, pretty similar to this, okay? So do it right now, just try to practice whether you can understand the usage of the find. I need all of you to practice both kind of the output, the column-wise index as well as the row column index right here. Okay, I think it is easy to find the indices with value larger than 10, right? all you need to do is simply replace the 6 by 10. And of course, you should use the relation operator like the larger than and the equal to, right? You need to use these two signs. Then you can easily get the indices with value larger than 10, right? This is the way. Okay. But for next question, can you find the indices with value between 10 and 20? Now think about this. You may try in this way. Between 10 and 20, some guy, I try this one. I guess some of you may try this description. So think about this. Do you think it will work or not? I have to say again, you are doing the MATLAB experiment. Just try it. Simply just press the enter. You will find out the result. So what would happen? Between 10, 20, it's more look like the 1, 2, 1, 3. You can see the indices. 1, 2, 3, 4 is pretty weird, right? Because the second element right here, definitely not within the range, right? It is not larger than 10. Okay, so it's something weird right here. Okay, I have to say this is not the correct description you should put. What you should do is you need to use this one. You need to use the logical operators right here. What is the logical operator? Take a look. If you are saying something like and you can say sometimes and is more like the overlap. Okay, the area intersect with each other, that is and. Or it's more like union. So you can match for the first criteria or maybe for the second one. This is or. Okay, you can buy me a sandwich or a hamburger. That means both are fine, right? But you can say you should buy me a hamburger and a sandwich. That means I want both, right? So if you say not, you can buy me a sandwich but not the hamburger. That means I had hamburger, okay? So it is a little different right here. So now, if you are going to find out the relation like the between, you need to put two relation description together. That means I want A to be larger or equal to 10, and I have to say and the shift with 7. Okay. And I want it to be this one. So take a look. What does this mean? That means A can be larger or equal to 10, right? And I need all the indices should have the value smaller or equal to 20, right? Okay, so only one? Let me check. Only one? Only 12, right? Only is one. So only the very first element fulfill the criteria, right? Okay, so this is the way that if you are going to say something, I don't know, with more than one condition, you can use and or this kind of a straight line. We always call it or. But this is a straight line that if you want to key this in, you should use a shift with the key that above the enter button, okay? Just try to find it out. So it pretty look like this one, okay? A lot of the straight line, okay? So once we know how to get value, I think set value. That means I'd like to put in the number or element into a specific location. I think this should be straightforward, right? So now we are going to rewrite the values at specific locations. For example, if I'm going to rewrite the value, if you are using the column-wise index, I'm going to rewrite the value located in the 7th position, right? So what you should do, again, if you're going to set means assign. So what you should do is now you can assign 100 to the 7th location if you are using the column-wise index. So now you can see the new matrix is look like this one. the original 7 is replaced by 100 because you are doing this kind of assignment. Pretty similar way, you can go for this one, right? A22, that means the row and column index. And again, you are going to assign 100 to it. So the results is identical, or the same, right? This is easy, so I'm not going to ask you to do the exercise. But if I'm trying to do this, I'm going to ask you, can you replace the value of 6 by 100? So that means you need to combine what you learned before, right? This is the way that you can find out the indices with the value equals to 6, right? So you can get a variable. This is the indices. So I can simply put these indices as the column-wise index as the input, right here. So I can assign all the 100 into these positions. Okay, so with these things, let me just show you. I think this is not that hard. So let me just show you. Okay. First of all, to find, right, I can find 5 specific location, right? So what I can do is I can use these indices as a location, right? I can assign 100 to it. So let me see what is the new matrix. Now you can see the original 6 become 100 right now. Okay, so you can combine these two usage right here, find, and the assignment right here. Okay. And in this case, I won't suggest you to use this output, because this way make everything complicated. For this case, you only get all the single value for each element, right? Because this is a column-wise index. But for this case, it's a little bit more complex because you get a 2 value for a specific position. So in this case, if you really want to replace something with some certain criteria right here, I would recommend you to go for a column-wise index. This is easy, okay? But this one, you need to deal with 2 different dimensions. This is a little bit difficult. You can still do it, but you need to use maybe for loop or something. I will introduce this later, but not today, okay? Okay, so right now, can I rewrite the values at a specific location? I have to say, for example, can I rewrite the values within, okay, this small matrix right here? Of course, you can do so. You just use what we learned before, right? You can either do the column-wise index way, or you can use the row column way. You can simply assign 100 to all of it, right? So I think this is pretty easy. So I'm not going to ask you to do the exercise, but just try to remember. You can combine what you learned. If you didn't put the assign right here, that means you are getting the value. But if you try to assign something into the matrix, then you are setting the value. Okay, I think this is the basic difference. And let me check. You can also do another way. If you don't want to assign all the same number within this area, what you can do is that you can assign a matrix or an array to the specific locations right here. For example, right now, I'd like to assign from 100, maybe 100, 102, 04, 01, 03, and 05 right here. I'd like to put all the numbers right here. Then you need to give an array if you are using the column-wise index. Because if you may recall that every single time when you are using a column-wise index, it's always output an array. Okay, you may remember this point. So if you try to assign something or set the value, do remember you also need to give an array. When I say array, it's more like the 1 by a certain number. For example, 1 by 6 array right here. Okay, but if you are using the row column index right here, now you are going to assign something into it. Again, you need to follow the rule, follow the dimension. Right now, in this case, it will be a 3 by 2 matrix. So when you are assigning something into it, you also need to create a 3x2 matrix right here. So now you can see, again, we have 6 elements, that's right, but I use 2 semicolons right here. That means I change rows, right? So now this is a 3x2 element, a 3x2 matrix right here. So please do compare. What is the difference right here? Again, for this one, this is more like a 1x6 array. For this one, this is more like 3x2 matrix. Okay, because for row and column index, it will preserve the dimension. That means you want to put something in, you need to put it in the right dimension. Okay. So there are 2 very useful functions that you should learn it, size and length. Today, we won't have the chance to practice it, but I want you to help it, to read through it right now. I'm not going to help you, you have to help yourself. So just try to do it. Help size and help length. I want you to read through the usage and description. Size and length. I do crop the very first description right here. Size is a function that can help you confirm the size of array. For example, you can try size with the A as the input. That means you can use the parentheses and put the A within the parentheses after the size, okay? So size, parentheses A, you can check what would you get. Again, length is more like the length of the factor or the largest dimension for the matrix, okay? Just try it. You can try to put the A as the input. That means you can try this, okay? I try to write it down. You just try this in the command window and tell me the results. If you try size, sometimes we say size of A, okay? It's pretty like the function, size of A, or size with the A as the input, length with the A as the input. So basically, for the upper one, size of A, you should get 2 numbers, right? 2 numbers like 5 and 5. That means you have 5 rows and 5 columns. If you are using length of A, you will get a single value like 5. And I have to say, if you are using a matrix with the matrix size like 3x5, you will still get 5 when you are using length of A, because it will simply output the largest dimension for you. So it will automatically ignore the smaller one, like 3. It will simply give you the output of 5. Just try it by yourself. You have to try it and help yourself, and you can learn it. So in the following, I think 2 or 3 slides, you may see so-called matrix operation. That means you can use the matrix to do some calculation. For example, A plus B or A minus B. I'm going to show you a very quick example. For example, if you have 2 different matrices together, for example, I'm going to create another matrix like this one. I have A, I have B right here. If I have 2 different matrices right here, can I use both of them to do some calculation? Of course. For example, I can do so-called A plus B. You will see the result element by element addition right here. So 12 plus 24, you will get 36, right? So it's more like A plus B. I think it's a very simple operation for the matrix. Also, I can do A minus B, right? Okay, so you can see the answer. Just element by element, element-wise calculation, okay? Can I do A with this multiply with B? Can I do this? For this case, the answer is yes. You can do this. You may find out this is a result. Let me just reshape my window. You may find out the answer is still a 5x5 matrix. But I have to remind you, this is not the element-wise operation. If you really want to do the element-wise operation, what you should do is, again, put this period right here. if you do remember, we mentioned this in the last week. If you want to do the element-wise calculation, you should put a period right here. So that means you are going to multiply all the elements of A with the elements we see in the B, element by element. So let's compare the results right here. So this is the result when you are using this one. The following results are the results from this one. And the only difference is this sign right here. So you can check, the very first one is 2008, but for this one is 282, right? But if you just check the number, this is 12, this is 24. So apparently, the following one, 288, is the result when you try to multiply the 24 with the 12 right here, right? So when you see this kind of the sign, I mean period, before the operator right here, this means I'm going to do some element by element or element-wise operation. Just do remember this, okay? So here are some basic rules that you can just read by yourself. So you can see this is a difference, okay? It's very important. So you need to remember what is the function of this period sign. And again, in the last week, we did try this one, right? Head right here. So when you are doing something like this one, A with the head and 2 right here, that means you are doing the square. So A is like this one, but you may find out this square is not element-wise. Again, this square means A multiply A. This is the matrix multiplication, right? This is not element by element. But if you are going to use this one, A period head 2, that means it's element-wise square. So 1, you can get 1. 4, you will get 16 because of 4 by 4, right? Okay, so this is kind of things you need to keep in mind, and I think you should memorize this by yourself, okay? And pretty similar, you can do the inverse. Okay, so these is some examples for you. Finally, this one is so-called transpose. Transpose. So you can see the example right here. You have A right here. When you try to do this A with a quotation right here, just single one quotation right here, it will become the matrix transpose. So you can see 1, 2, 3. Now 1, 2, 3 come to this side. That means switch row and column. Okay, switch row and column, exchange row and column. So now 1, 2, 3 is the first column. It becomes the first row right here. 1, 4, 7 is the first row. It becomes the first column right here. Okay, so this is so-called transpose. Transpose, okay. So sometimes you may see some error message when you are doing the matrix operation. Again, I have to say, don't be scared. Don't be scared of the error message. Just read through it. It may give you some hint. So I try to give you all the possible error message that you may see right here. But I just try to ask you to read through it. So I'm going to give you just 1 minute. Please just read through all the content and make sure that you can fully understand all the matrix operation, okay?